Hello everyone, welcome to today's lecture. So today we are going to start with chapter 3. We have finished with 4 chapters. Okay, hope you are studying each and every chapter. Reading the textbook is very important. Okay, so we are going to start with chapter 3, that is current electricity. The first part is just a revision which you had studied in your 8th standard, page number 30, all around us. Okay, in those 3 paragraphs they have given the use of current electricity. Where do we use current electricity? We use current electricity in our appliances, in our homes, and for us life is difficult without electricity. We depend upon electricity very much. The basic thing is for charging our mobile phones. Okay, for charging our mobile phones, for lighting our houses. So these are the basic needs of electricity. Besides, there are other needs also. Now, can you recall? You must have seen a waterfall. Which way does the water flow? It flows from a higher level to lower level. For the generation of electricity, water is released from a dam at a higher level, and because of gravity it falls to the lower level. Thus, as we know, the direction of flow of water between 2 points depend upon the level on 2 points. Now next, figure 3.1, you may see they have taken a setup in which one bottle is kept at a higher level and another bottle is kept at a lower level. At first they have closed it with a clamp. Okay, so when the clamp is put, the water won't move from one bottle to the other. Okay, but if we add water to the bottle which is at a higher level and the clamp is removed, then the water will flow from the higher level to lower level. Till when it will move? It will move till the levels in both the bottles will be the same. Now the question is, what happens when the clamp is removed? When the clamp is removed, the water will flow from the bottle which is at a higher level to the bottle which is at a lower level. Does the water stop flowing? Yes. When it stops flowing? When the level becomes the same. Why? Because there is no difference. Okay, so there should be a difference between the two levels. One should be at a higher level, another should be at a lower level. So as there is no level difference, the flow will stop. What will you do to keep the water flowing for a longer duration? What you will have to do? You will have to go on adding water to the bottle at the higher level. Okay, you have to go on adding water to the bottle at the higher level. Then the water will flow from higher level to lower level. Okay, so there should be a difference in their levels. So this difference is necessary for the flow of current also. This difference is called as potential difference, and the caliber, the capacity of one level, that is said to be electric potential. So we will see, just like water, the flow of electric charge between the 2 points depends on a kind of electric level at those points. This level is called electric potential. Okay, so there is an electric potential. Now we may move on to the next page, that is page number 31, figure 3.2. I have drawn the diagram here. They have made two setups. Okay, they have made two setups. This is at a higher electric potential and this is at a lower electric potential. These are stand with insulating material and there is a conducting wire. This is a stand with higher electric potential and this is a stand with lower electric potential. In which direction will the current flow? The current will flow from positive to negative, that is from higher potential to lower potential. So basically you should understand there is an electric potential. Potential, what do you mean by potential? It is the caliber, it is the ability. Okay, the ability which this has, this is having more ability. This is having less ability. In case of current, it is measured in terms of electrons. Consider this is having more electrons and this is having less electrons. So the electrons will move from negative to positive. Actually, we will come to that afterwards. But as the number of electrons are more, it is said to be at a higher potential, and as the number of electrons are less, it is said to be a lower potential. I am giving you as an example. Okay, so the electrons will move from higher potential to lower potential. So there should be a difference in their potential, that is electric potential. That difference is called as potential difference. Now you may take page number 31. A positive charge flows from a point of higher potential to a point of lower potential. Okay, so a positive charge flows from a point of higher potential to a point of lower potential. You should note that it is positive charge. Positive charge moves from positive to negative. Okay, we have seen earlier that electricity flows due to conduction of negatively charged electrons. Electrons flow from the point of lower potential to a point of higher potential. Underline that. It is a very important fill in the blank. Now, why do electrons flow from lower potential to higher potential? Because electrons are basically negatively charged. As they are electrically negatively charged, they will move towards the positive. So negative charge is considered to be a lower potential and positive charge is considered to be a higher potential. So as it moves from negative to positive, they are negative on their own. They are moving towards positive. So it is said that electrons move from negative lower potential to higher potential. They move from negative to positive. What about positive charges? Positive charges are positive on their own. They will move towards negative. So it will move from higher potential to lower potential. I repeat, electrons are negatively charged. So they are at a lower potential. They will move towards positive. As they are negatively charged, they will move towards positive. Okay, so it is said that they move from negative charge to positive charge, or lower potential to higher potential. A lightning strike is the flow of electrons from a point of lower potential on the clouds to the point of higher potential on the earth. Okay, so it is the flow of electrons. We shall study the definition of electrical potential in higher standards. Now, the difference between the value of potentials at 2 points A and B is called the potential difference between them. Okay, it is between them, that is not the definition of potential difference. In figure 3.2, conductor A is at a higher potential than conductor B. When these two are connected by a wire, a potential difference is created between its two ends and electrons will flow from B to A. Okay, I told you the current flows from A to B, but the electrons will flow from B to A, from lower potential to higher potential. Why? Because they are negatively charged and they will move towards positive charge. This flow will continue until the two conductors A and B have the same potential, that is until their potential difference becomes 0. Okay, so from this we have to understand that the current will flow if there is potential difference. I repeat, the current will flow if there is potential difference. If there is no potential difference, the electrons don't flow. And who provides the potential difference? The potential difference is provided by the cell or the battery, okay, or the supply. Okay, now we will see potential difference of a cell. The difference in potential between the positive and negative terminals of a cell is the potential difference of that cell. Okay, now I will explain the definition. You may see the electric potential difference. Now this definition which you will be getting this year will be define electric potential difference. What is electric potential difference? So there is a potential difference, the amount of work done to carry a unit positive charge from point A to point B is called the electric potential difference between the two points. So some work has to be done to move a unit positive charge, one positive charge from A to B. A to B are any two points. Okay, so the amount of work done to carry a unit positive charge from point A to point B is called the electric potential difference between the two points. Okay, it is very important. The definition is very important. What is the equation? The equation is V is equal to W upon Q. You are having this next year also. You don't have any explanation. If you are having any doubts in this, you may refer to chapter 4 of standard 8. If you remember things, okay. If you remember things, it is good. If you don't remember, just go through chapter 4 of standard 8. Okay. So what is electric potential difference? It is the amount of work done to carry a unit positive charge from point A to point B. V is equal to W upon Q, where V stand for potential difference, W stand for work done, and Q is charge of an electron. Okay, an electron is having a charge. Which charge? Negative charge. Negative charge means how much it is. It is about 1.6 into 10 raised to minus 19 coulomb. That we will be seeing afterwards. Okay, so there is a particular value for that charge. Okay, charge means how much? 1, 2, 3, 4, how much? Okay, so there is a charge for an electron. So how many charge? How much charge? Okay, so what is potential difference? Potential difference is equal to work done upon charge. Okay, the equation is given in the textbook. Potential difference between 2 points is equal to work done upon total charge transferred. The transferred means the electrons are moving from one place to another. That charge which is transferred. So that is V is equal to W upon Q. I repeat, V is equal to W upon Q, where V stand for potential difference, W stand for work done, and Q stand for charge of the electrons. Now, the unit of potential difference is volt, V-O-L-T, volt. 1 volt. Now, the unit of work done is joule. So, 1 joule. The unit of Q, that is charge, is coulomb. You may see the spelling here, coulomb. Okay, so 1 volt is equal to 1 joule upon 1 coulomb. This could be asked as a fill in the blank question also. Okay, so this much you may mark on that page. It is very important. Now, towards the end of page 31, they have given a diagram of the structure of an atom. What do you mean by free electrons? Now, you had studied the structure of an atom. There is a nucleus at the center. This is the nucleus. Then there are orbits around it. Now, the electrons in the outermost orbit, whatever the number of electrons may be, either 1 or 2 or 3. Okay, you had studied last year, if there are 1 or 2 or 3, they will lose electrons. Lose electrons means they have a tendency to give away those electrons. They are not in affection with those electrons, we can consider. Okay, they are ready to give away those electrons. Those electrons are called as free electrons, and it is those free electrons which are moving through the wire. Okay, so basically metals are good conductors of electricity. Why metals are good conductors of electricity? Because they are having free electrons. Okay, because they are having free electrons. Now we may move on to page number 32. There is a box, an introduction to scientist. The Italian scientist Alessandro Volta constructed the first electric cell. The unit of potential difference is named volt in his honor. Okay, so Volta's simple cell, electric cell they have given. Now there is a do you know box, which is a very important fill in the blank or objective type question. 1 millivolt, just like millimeter, we are having millivolt. 1 millivolt is equal to 10 raised to minus 3 volts. 1 microvolt is equal to 10 raised to minus 6 volts. 1 kilovolt is equal to 10 raised to 3 volts. Just like 1 kilogram is 1000 gram. Now 1000 is same as 10 raised to 3, isn't it? 1 megavolt is equal to 10 raised to 6 volt. These are all fill in the blanks. Okay, so you may mark this much in your textbook. Now the next topic is current flowing through a wire. Now you know about a wire. You have seen an insulated wire. Insulated wire means it is having a rubber coating. Inside that wire there is a copper wire. If you have not seen, you may take a wire, okay, the wire which is not in use, okay, not the live wire, not the wire which is connected, the wire which is lying of not any use. You have to take that, you have to remove the insulation and see, okay, you may see a copper wire inside, okay. Now that is actually the metal which is conducting the electrons. So when the wire is not in use, these are the electrons inside. In the wire, the atoms of copper is there, okay, the atoms of copper. I am telling you copper because basically we make use of copper wire, okay. Now atoms of copper is there. Atoms of copper means they are having their structure along with their electrons in the outermost shell. Those electrons and those atoms or ions, they are vibrating in the wire. They are vibrating, they are in a vibrational motion. They are just sitting there idly, okay, they are not doing anything, they are just sitting there. But when it is connected to a cell, this is the diagram 1. That means when it is not connected to any cell, they are moving in any directions. I have shown the directions, they are moving in any directions. But when it is connected to a cell, this is the positive terminal, this is the negative terminal, okay, positive terminal of the cell and negative terminal of the cell. How can I tell which is positive and which is negative? The longer line is positive and the shorter line is negative. It is the symbol of a cell. You had studied this in your earlier classes. So this is a cell. When it is connected to a cell, what happens to the electrons inside? What happens to those electrons which are free to move? Okay, the copper is ready to give those electrons. What happens to those electrons? Those electrons are having which charge? They are having negative charge. So it will move towards the positive. Okay, it will move towards the positive terminal of the cell. So you may see that the electrons are moving in this direction. Okay, all the electrons are in the same direction. You may say it will move towards the positive. Okay, but in which direction does the current flow? The current is said to flow from positive to negative because everything flows from higher potential to lower potential. But basically what is current? It is the flow of electrons and it is moving from negative to positive. But conventionally the current is said to flow from positive to negative. So this is what is happening inside a wire. Okay, you may see on page number 32, you may read out that those paragraphs. Page number 32, free electrons. Every atom of a metallic conductor has one or more outermost electrons which are very weakly bound to the nucleus. These are called free electrons. As shown in figure 3.3, these electrons can easily move from one part of the conductor to its other parts. The negative charge of the electrons also gets transferred as a result of this motion. The free electrons in a conductor are the carriers of negative charge. But when we talk about electric current, the current is said to be the movement of positive charges. On page number 33, there is a box, green box, you may see. Even though electrons move from negative end to the positive end, conventionally the direction of current flow is taken to be opposite to the direction of flow of electrons, that is positive end to the negative end of the cell. Now why it is so? Because the current flows from higher potential to lower potential. The current is flowing from higher potential to lower potential. So to make it higher potential to lower potential, it is said to be the movement of positive charges, and it is moving from positive to negative. But basically current is flow of electrons from negative to positive. Okay. Now what is current? How it is defined? How do you define electric current? The charge passing through a conductor in unit time. That is the definition of electric current. You may mark it in your textbook. What is the definition of electric current? It is the charge passing through a conductor in unit time. I is equal to Q upon T, where I stand for current, Q stand for charge, and T stand for time. From this equation you can write the definition. What is I? I is Q upon T. I is Q upon T. So what is I? I is Q. That means the charge passing through the conductor upon T in unit time. Okay. So the charge passing through conductor in unit time is current. I is equal to Q upon T. Now what is the charge of one electron? The charge of one electron is 1.6 into 10 raised to minus 19 coulomb. You may mark it in your textbook. It is an objective question. Now 1 ampere. What is ampere? The unit of I is ampere. The unit of Q is coulomb. The unit of T is second. Okay. Now what is 1 ampere? 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it in every second. So 1 ampere is equal to 1 coulomb upon 1 second. From this equation, I will tell you the definition. What is the equation? 1 ampere is equal to 1 coulomb upon 1 second. So the current is said to be 1 ampere when 1 coulomb is flowing in 1 second. Okay. So the current is said to be 1 ampere when the current flowing is, the charge flowing is 1 coulomb in 1 second. Okay. So I repeat, ampere. 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. That means in 1 second. That means 1 ampere is equal to 1 coulomb upon 1 second. So whenever you learn the definition, you have to see what is the equation. Always there is an equation. Especially in physics, there is an equation. So first you have to see the equation. So according to the equation, the definition is there. It is there always like that. Okay. So you may first learn the equation, then learn the definition. Now the definition should be according to the textbook. Whenever you write a definition, you may write the equation below. Okay. So even if you go wrong in your definitions, you might get marks for the equation you have written correctly. Okay. So it is just a trick, nothing else. You may always write the equation, but for that you have to learn the equation also and the definition also. Okay. Now in the box you may see 1 milliampere is equal to 10 raised to minus 3 ampere and 1 microampere is equal to 10 raised to minus 6 ampere. Even this is a fill in the blank. Okay. Objective type question. Now in the box, do you know box? You may see the French mathematician and scientist Ampere conducted a number of experiments on electricity. Today we can measure the current flowing in a conductor only because of his work. The unit of current is called ampere in recognition of his work. Now one solved example has been given. You may mark it as very important. It is very frequently asked. A current of 0.4 ampere flows through a conductor for 5 minutes. So they have given the current. Ampere means it is the current, and minutes means it is the time. That minutes you have to convert into seconds. How much charge would have passed through the conductor? I is given as 0.4 ampere. T is 5 minutes, so 5 into 60, that is 300 seconds. And with this equation, I is equal to Q upon T, you have to do the numerical. Okay, so today we have studied two equations. One is V is equal to W upon Q. Okay, the first equation is V is equal to W upon Q, where V stand for potential difference, W stand for work done, and Q stand for charge. The second equation is I is equal to Q upon T, where I stand for current, Q is charge, and T is time. What is the unit of potential difference? It is volt. What is the unit of work done? It is joule. What is the unit of charge? It is coulomb. What is the unit of I, that is current? It is ampere. What is the unit of Q? It is coulomb. What is the unit of T? It is second. This much you have to learn today. So we have learned two equations today. V is equal to W upon Q and Q is equal to IT, or I is equal to Q upon T. Okay, in this chapter there are several equations. So one by one we will learn. Each and every day you may write these equations. Whenever you finish the lecture, you may write it 5 to 10 times in your notebook. The two equations for today is V is equal to W upon Q and I is equal to Q upon T. Okay, now I'll give you the homework. Now this is the homework for today. Define electric potential difference, current and 1 ampere. With equation you have to write, and you have to write the formulas which we have learned today 5 times. V is equal to W upon Q and I is equal to Q upon T. Okay, you have to write what does V stand for, what does W stand for, what does Q stand for, everything you have to write. Okay, 5 times, so that you will be thorough with the equations first. So you may mark everything in your textbook. First complete reading this part, then do the homework, and then learn the equations and the definitions. Okay, thank you.